any doubts with regard to the previous session of conicoid, what we discussed so far to all? Any questions or doubts to anyone? All right. So let us begin our today's session. So this is the first problem, what I am going to take. So just give me a moment. Find the locus of the point of intersection of three mutually perpendicular tangent planes to the central conicoid ax square plus by square plus cz square equal to 1. So please take a note of this problem. Later we discuss with the approach. Right. So this is our given conicoid. In the previous class, we know how to consider the tangent plane equation. Generally, we write it as Lx plus My plus Nz equal to P, where P stands for the distance. And obviously, we got an expression for P also. Can you recollect? How do we calculate the distance P? I have given a formula that square root of the value for P. So it is nothing but square root of L square by A plus M square by B plus N square by C. So if we read the question, we have to calculate the locus of the point. And how the point is obtained? The point is nothing but the intersection of three perpendicular tangent planes. So this is the general form of the tangent plane we consider. So here we need to consider three mutually perpendicular tangent planes. So let us write them. So L1x plus M1y plus N1z is equal to, this is one tangent plane. The second one will be L2x plus M2y plus N2z is equal to square root of L2 square by A plus M2 square by B plus N2 square by C. And the third tangent plane, if you consider L3x plus M3y plus N3z equal to square root of L3 square by A plus M3 square by B plus N3 square by C. So here we have to consider that these three planes will intersect. It is nothing but a point. So the point XYZ is the point of intersection of the all three tangent planes for this conicoid. Clear? So for a small visualization, if you say that this is the surface, for this surface I have considered three tangent planes. This is one tangent plane, this is the other one, and the other one is perpendicular to this. The intersection of these planes is nothing but a point. This point also lies on the conicoid. Okay? Clear now the perspective? In the other way around, you can say that whenever you consider a surface, if you take a point on it, at this point you can consider three mutually perpendicular tangent planes. That you can understand. Clear? Yes or no? So, I want to find a locus condition satisfied by xyz from the planes. In other words, I want to eliminate the values of L1, M1, N1, L2, M2, N2, etc. so that I will get a condition in terms of xyz. So which is nothing but the required condition. So using the planes, I am eliminating LMN values which will result a condition to me in the terms of xyz, which is the desired locus. Clear? Yes or no? Are you getting the idea behind it? Fine. So, you square both sides for each equation. Let us take squaring on both sides. First equation, second equation, third equation. So we do squaring on both sides. Now add the three equations. So what you will get in terms of L1x plus M1y plus N1z whole square plus L2x plus M2y plus N2z whole square plus L3x plus M3y plus N3z whole square equals to first one L1 square by A plus M1 square by B plus N1 square by C plus L2 square by A plus M2 square by B plus N2 square by C and again plus so this is the equation we got. So we do squaring on both sides. For the three equations, I am adding the result. Clear? Now what happens? You are going to expand the terms. Expand this using A plus B plus C whole square. Again expand this. Again expand this. Now I am going to take the terms as common. X square term, Y square term, Z square term. The coefficients xy, yz, zx, etc. So the result will come as, I will make space here. It is going to be x square into L1 square plus L2 square plus L3 square plus y square into plus you have the values So these are the values we will get here if we add and take the terms as common. Please check on. Anybody has any doubts with regard to this, you can ask. All right. Now, please understand that LMN values are DCs and the set of values what you are taking are mutually perpendicular. So you have studied the properties of the DCs earlier at +2 level. So using the properties of DCs, this value is 1, this value is 1, this value is 1. And these values will become 0 whenever you multiply with the different values. So this becomes 0, this becomes 0, this becomes 0. So as a result, it will come as x square plus y square plus z square is equal to 1 by a plus 1 by b plus 1 by c. This is the result. So here the coefficients will become 1, 1, 1. Here 0, 0, 0 you will get. Again on the right hand side you have 1, 1, 1. Please check on this. Any queries you ask. So is it clear to all how it came? Right. Now, this is the required locus. We have completed the problem. So this is the solution for the problem. Now, on looking this equation, what can we say about the locus? In other words, if you observe that the equation is looking like x square plus y square plus z square is equal to r square, is it similar to this pattern? Say. So this kind of locus results to what to us? This kind of locus we call it as with the name sphere. Agreed? So if you read the question tag, whenever you consider a central conicoid, if you consider 3 mutually perpendicular tangent planes, such tangent planes as and when you consider the point of intersection of that tangent planes on the conicoid will constitute a sphere for us. That sphere we call with the name as director sphere. So it has the center 0, 0, 0, nothing but the center of the conicoid, you say. And radius it is given by there 1 by a plus 1 by b plus 1 by c, if you take it as r square. So the thing we need to remember here is director sphere means the locus of the 3 mutually perpendicular tangent planes intersection gives us a sphere on the conicoid. That sphere we are calling it as the director sphere. Okay. So this is one of the previous question. So please take a note of that. If you are clear with this approach, I take the next one. Now tell me, are you feeling any difficulty in getting the questions and solutions of conicoid as per the discussion what we made now? So that I will modulate myself. Or is it comfortable for you? Right. So this is the second question. find the length of the perpendicular from origin on the tangent plane at the point x dash, y dash, z dash of the ellipsoid x square by a square plus y square by b square plus z square by c square equal to 1. Take a note of it. Right. So this is the given ellipsoid. For this ellipsoid, what we are doing, we are taking a point on the ellipsoid and we are calculating the tangent plane. So if you consider the tangent plane with respect to that point, we have a formula already there. It is x dash by a square plus y dash by b square plus z dash by c square equal to 1. This is the tangent plane equation at the given point for the ellipsoid. You can write it as taking 1 to this side, minus 1 equal to 0. This is the equation of the tangent plane. And we have to calculate length of the perpendicular from origin to the plane. In other words, you are calculating the distance, let us say. So this is the plane we have. We are calculating the distance from origin to the plane. So we have a formula there earlier. This is the formula we use actually to calculate the distance. Can you remember? Right. So let us take that P is the distance. Let us assume that P is the distance from origin to the plane. Let us assume that. So you have, applying the formula, P is equal to modulus of, substituting the values here, 0 plus 0 plus 0 minus 1 by square root of x dash by a square whole square plus y dash by b square whole square plus z dash by c square whole square, where a, b, c, d are nothing but the coefficients in the plane you have taken. So x dash by a square, y dash by b square, z dash by c square, d is nothing but the constant minus 1. Okay? Clear to all? Now, let us take reciprocal on both sides and do squaring on both sides. So you have the thing that x dash whole square by a power 4 plus y dash whole square by b power 4 plus z dash whole square by c power 4 is equal to 1 by p square. This is the value. Because we are calculating the distance from the origin, right? So x1, y1, z1 is nothing but 0, 0, 0. The distance point. You are calculating the distance from origin. A, B, C, D, nothing but values in the plane. I have applied the formula directly. So that is nothing but the desired solution. Okay? the length of the perpendicular you can call upon. So take a note of that, then I will take the next problem. So the best approach in conicoid is if you clearly understand the problem statement and do the process step by step, taking the technical terms in the problem statement, then we will achieve. Majority of the problems will be achieved by doing like that. Just one or two will need a little modification. That's all. So if you are clear with this solution, then I take the next problem. So this is our next question. So this is one interesting question. So I will read the statement. In the meanwhile, you take a note of it. If P and Q are any 2 points on the ellipsoid, the plane through the center and the line of intersection of the tangent planes at P and Q bisects PQ. That was the question we have to show. Clear now? Now let us try to imagine the picture for it. So let us say this is our ellipsoid. Now I have taken 2 points on it. Let us say this is my center. This is one point P. This is another point Q. So I am considering the tangent planes at PQ. So at P, I am taking a tangent plane. At Q, I am taking a tangent plane. And one interesting thing is, I have to take the line of intersection of the tangent planes. In other words, the 2 tangent planes are intersecting, there you will get a line. So for my visualization, I feel that this is one tangent plane, and again you will have another tangent plane. So you will get the line of intersection here. There you will get a line. Clear to all? It is just like you take a ball, on top of it, on bottom of it, you place 2 planes like this, 2 planks. There you will get a line of intersection. Fine. For a small visualization, if you talk of circle, say this is the actual thing you are doing. These 2 are intersecting. This is for the idea. So this is P, this is Q. Okay? For the visualization part. Any difficulty for anybody? Right. Now, the actual thing you are doing is, you have to calculate a plane, and what is the property of the plane? It is passing through the center and the line of intersection. So at this position, I have to calculate a plane which is passing through the line of intersection and the center. So this is the plane I am calculating. So, and what is the question tag of the problem? This plane bisects PQ. So the plane is bisecting the PQ. That was the question tag we have to prove. So the thing we need to understand here is the plane what you are calculating, it bisects PQ. This is our task. We have to show that. Okay, now the overall idea behind the problem, please say. Right. Now just understand that if the plane bisects PQ, in other words, let me say I have the plane equation with me. I am saying that this is a line, the plane is bisecting the line. In other words, how can I justify that the plane bisects the line if this is the line segment, say? What could be my checking condition that the plane bisects this line segment PQ? That is one good point, distance is same. Another thing, okay, as and when you consider the normal, the distance will come. I agree. So you are saying that the normal, if you calculate, it is perpendicular to the plane that we apply, right? Then, so in the other way around, if you think, whenever you have 2 points, can we consider the midpoint of it? Can we consider the midpoint of PQ? So can I say that the midpoint lies on the plane as it is bisecting? So that is the thing we do actually here. So the whole phenomena, what I am going to do is, using the given data of the problem, I want to compute the plane equation first. Second, I show that the midpoint will satisfy the plane equation. So there the problem completes. That is the whole idea. Okay. Now let us do with the procedure. So let us take that P x1, y1, z1 is one point. Q x2, y2, z2 is another point, which are taken on the ellipsoid. So it is x square by a square plus y square by b square plus z square by c square equal to 1. This is my ellipsoid. As I am considering the tangent planes at the first point, at the second point, the tangent planes for me are nothing but so this is the tangent plane at P, this is the tangent plane at Q. Agreed? Now, what we have to calculate? The plane passing through line of intersection, right? So, whenever you have two planes, how do we calculate another plane passing through them? Can you get the formula from the planes chapter? I will say it will be pi 1 plus lambda pi 2 equal to 0, the formula we use. So this formula we are using to calculate a new plane which passes through the intersection of two planes. There you have solved so many problems on that. So if you take this is pi 1 and this is pi 2, so you have pi 1 plus, for lambda I will take k into pi 2 equal to 0. So all I need to do is I have to calculate the value of k, what it is. One more condition in the problem is the plane is passing through the center. So by default it is nothing but origin. The ellipsoid is centered at the origin. The problems all of us we are doing as origin 0, 0, 0. So in place of x, y, z here, if you substitute 0, 0, 0, you will get that k is equal to minus 1. Check on that. Substitute 0, 0, 0 in place of x, y, z, you will get k is equal to minus 1. Say, right. Now, if I substitute k is equal to minus 1, then what happens? I get the required plane. And the required plane happened to be x into x1 minus x2 by a square plus y into y1 minus y2 by b square plus z into z1 minus z2 by c square equal to 0, because the constant value minus 1 gets cancelled if I substitute k is equal to minus 1 there. Accepted? So this is my required plane. So I have done with half part of the problem. So I have calculated the plane equation here. Now what I need to do, I have to show that this plane bisects PQ. As we discussed earlier, if you take the midpoint of PQ, the midpoint of PQ lies on it. In other words, if you substitute the midpoint of PQ in place of x, y, z, you should get 0. Okay? Are you getting the thought? Yes or no? Fine. So I am saying that our question tag is the new plane what you have calculated is bisecting PQ. That is our task. Agreed? Read the question tag of the problem once. Accepted? Right. And we discussed the approach that how do we show that the plane is bisecting the line segment. So as per the discussion, we agreed that if you take midpoint of midpoint of PQ, that midpoint lies on the plane, so that it will bisect the line segment, the plane. Agreed? So this is the point x1, y1, z1. This is the point x2, y2, z2. So what could be the midpoint here? This is the midpoint of PQ. Now, if I substitute the midpoint in the plane equation, it must get satisfied. So in place of X, Y and Z, I am substituting this midpoint. So on substituting, what happens? Let us see. So if you substitute here, it is nothing but x1 plus x2 by 2a square, y1 plus y2 by 2b square, z1 plus z2 by 2c square. This is the thing you will get if you substitute in the plane. Accepted? Right? Now, in the numerator, it is of the form a plus b into a minus b. You have to simplify that. So I will say you are going to get it as, so x1 square minus x2 square by a square plus y1 square minus y2 square by b square. This is the thing you got. Now you can separate the values also here. So I can write it as agreed. I have just separated the terms. Right. Now please understand that this is my ellipsoid equation. That is the ellipsoid equation I have taken. And I have taken 2 points on it. One point is P, one point is Q. And these points are taken on the ellipsoid. It means that they will satisfy the ellipsoid equation. So you have x1 square by a square plus y1 square by b square plus z1 square by c square is nothing but 1. Similarly, for the other point also you will get 1. So this is nothing but 1 by 2 into 1 minus 1 by 2 into 1, which gives that the value as 0. Therefore, the midpoint what you have taken there is satisfied the plane equation. Hence, the plane bisects the line segment PQ. That was the complete solution. Clear? Is the discussion good for you? The overall approach of the problem? Right. Now I will take the next concept. Shall I proceed? So take a note of this problem. So the problem seems to be somewhat lengthy, but it is very easy to solve if we understand the concept in a proper way. So once you have taken a note of it, then inform, we discuss with the approach. Now, so what we are doing actually, the problem has two parts here. Let us do with the first part of the problem. We got an ellipsoid with us. This is the ellipsoid. For this ellipsoid, we are considering a tangent plane, and the tangent plane will intersect the coordinate axis at the points ABC. So whenever you have considered a tangent plane which is cutting the coordinate axis, obviously we will get a triangle. So we have to find the locus of centroid of triangle. That is the first part of the problem. Clear? Say yes or no. So if you imagine the picture, a small picture let us draw. So this is the ellipsoid. By default, center is origin. Let me say this is the tangent plane I have taken. So this tangent plane is cutting x-axis, y-axis and z-axis also. Since it is not possible to draw completely on the blackboard, it is 2D. So imagine that it is 3D. The plane is cutting x-axis, y-axis and z-axis. So this is the point A, this is the point B, this is the point C. There you will get a triangle. Now in the first place, we write the tangent plane equation to the ellipsoid. Let us write it first. So it is nothing but x1 by a square plus y1 by b square plus z1 by c square is equal to 1. Now, as and when it meets the coordinate axis, always we will get the intercepts, isn't it? The intercepts we will get. Now, if you want to get x-intercept, what you have to do? If you substitute y and z values 0 in the plane equation, you will get x-intercept. Accepted? Right. So if I substitute y and z as 0 here, you will get that x1 by a square is equal to 1, which gives that x is equal to a square by x1. Agreed? So what could be the x-intercept here? A square by x1 comma 0 comma 0. Getting the idea how it is written? The intercept. Similarly, you can substitute x and z0 here, you will get y-intercept. So it is nothing but 0 b square by y1 0 and z-intercept 0 0 z square by c1. I mean c square by z1. Please check on that, how I have calculated the intercepts. Right. Now see, whenever you consider the tangent plane, it touches the conicoid at the point. this is the point of contact x1, y1, z1 for that tangent plane. So what happens? The point is common to plane as well as ellipsoid. So the point satisfies the ellipsoid equation. So you have x1 square by a square plus y1 square by b square plus z1 square by c square equal to 1. Accepted? Are you getting the idea or not? Now, the actual thing we have to do is, you have to calculate locus of centroid of triangle ABC. You know the three vertices of the triangle. This is vertex A, this is vertex B, this is vertex C. Now let us take that alpha, beta, gamma is the centroid. So if you have taken that alpha, beta, gamma is centroid, so you have alpha, beta, gamma equals to, so for the three vertices, if you apply the centroid formula, you will get that a square by 3x1, b square by 3y1, c square by 3z1. So if you equate the respective values, you get that x1 is equal to 3 alpha by a square, y1 is equal to 3 beta by b square, and z1 is equal to, x1 is equal to a square by 3 alpha, y1 is equal to b square by 3 beta, and z1 is equal to c square by 3 gamma. Please check that. So for the vertices, I have applied the centroid formula, I have equated them, I get the values of x1, y1, z1. Now I am going to substitute x1, y1, z1 values in this equation, because the point is satisfying the ellipsoid equation. So if you substitute here, you will get the value as the locus you can call upon. Equals to 9. That is the locus satisfied by alpha, beta, gamma. I am substituting x1, y1, z1 in this equation. Are you getting it or not? So I have written the equation satisfied by alpha, beta, gamma. This is the locus satisfied by alpha, beta, gamma. So please substitute x1, y1, z1 values here, and then check with this answer, the locus part. If you have done with it, then I move ahead with the second part of the question. All of you, please check that. If everyone confirms the answer here, then I take the second part of the problem. After substituting x1, y1, z1 in this equation, you will get the locus of alpha, beta, gamma. The locus is nothing but this. This is the equation satisfied by alpha, beta, gamma. Right. So you have done the first part of the problem. Let us go with the second part of the problem. Second part is very easy. Now what it is given, if you take that P is the point of contact and you consider perpendiculars from point of contact to x-axis, y-axis and z-axis. The names are taken as PD, PE and PF. So you have to prove that the values will come as OD, OA equal to A square, OE, OB equal to B square, like that. Okay. That was the second part. So for a small visualization, let us take that. This is the point P. This is the tangent plane you got. This is A, this is B, this is C. The coordinates of A are nothing but x, 0, 0. The coordinates of B are nothing but 0, y, 0. C are nothing but 0, 0, C. And from this P, you have taken perpendicular D, perpendicular E. Here you have perpendicular F. And what I am taking? x1, y1, z1 is the coordinates of P. Are you visualizing that? PD, PE, PF. So, if I say that, please understand, whenever you have specified the coordinates of a point, so here this is origin, so OD is nothing but the x coordinate x1, accepted. If you want to consider the LHS part, OD into OA, it is nothing but OD is x1, OA is x. Earlier you have proved that while taking the intercepts, you have the part that x1 by a square is equal to 1. This implies x1 is equal to a square. So x is nothing but OA, x1 is nothing but OD is equal to a square. Clear? We have written the first thing. While writing that tangent plane, if you want to calculate x-intercept, I have to substitute y is equal to 0, z is equal to 0. There you will get this relation. So if you have a doubt, I will write it again. This is my tangent plane to the ellipsoid. In the first place, I have considered. So to know that what are the intercept made by this tangent plane, if I want to know what is the x-intercept, I have to substitute y is equal to 0 and z is equal to 0. So from this I will get x1 by a square is equal to 1, which is nothing but x1 is equal to a square. So x is nothing but OA, x1 is nothing but OD is equal to a square. Fine. Similarly, the other things will come. OE, OB is equal to B square, OF, OC is equal to C square from y-intercept as well as z-intercept. That's all. The second part is very simple one. Nothing is there to prove. First part is somewhat interesting if you consider the logic. So after proving that OA, OD is equal to A square, we mentioned that similarly by considering y and z intercepts, we will have this equal to B square and this equal to C square. That's all. that we will mention. There is no need to calculate them separately. Okay. Have you done with it? Right. Now I will give you a small problem. So before this, in the first part of the problem, we discussed about the locus of centroid of triangle ABC. Now if the question is asked that find the locus of centroid of, say, tetrahedron OABC. Tetrahedron OABC, if it is given, calculate the locus of centroid of tetrahedron OABC. The same problem statement is there. Apart from calculating centroid of the triangle, it is given that calculate centroid of the tetrahedron. Then you will get the locus equation as a square by x square plus b square by y square plus c square by z square equal to 16. Earlier you have the locus equation equal to 9 because there you got centroid of triangle. Here you are calculating the locus of centroid of tetrahedron, so it will come as 16. So you can solve it on your own. It is a very easy problem. The same pattern you will do. Okay, you please take a note of it. So is it required for you to solve that model also? The same equation will come, only constant will vary. Right. Now I will give one small problem for you. That also you take it as a practice. Then we discuss something interesting. So this is the problem. This is the problem. You just take it as a practice. I will say you are going to get it as the value maybe 8 by 3, 4 by 9, 2 by 3. So you just calculate the tangent plane equation at the point 1, 1 by 2, 1. So convert that tangent plane into intercept form. Just like as and when you get the tangent plane equation, you convert the form in the form of so after finding tangent plane, you convert this into intercept form. So x-intercept, y-intercept, z-intercept you will get. So calculate the centroid. That's it. Are you able to do? The answer is 8 by 3, 4 by 9, 2 by 3. So take a note of that problem. Then I will discuss the interesting problem. So take a note of this problem. Then we discuss with the approach. So it is very similar problem. Apart from taking the ellipsoid, I have taken the conicoid. So say this is a surface, the conicoid. So for this conicoid, I have considered the tangent plane to it. And the tangent plane, it meeting the coordinate axis at the points P, Q and R. So obviously, you will get the triangle PQR. So you have to calculate the centroid locus for it. The general question as we did earlier. So let us write the tangent plane as Lx plus My plus Nz is equal to P. So we got an unique expression for P, the distance. So the required tangent plane or the actual tangent plane is nothing but L square by A plus M square by B plus N square by C. So this is the actual tangent plane of the conicoid. Okay. Now what it is doing? It is intersecting the coordinate axis. So we have to convert this plane into intercept form. How do we do? You have to divide with the constant. So on dividing with this number both sides, you can write it as x divided by square root of the value what you got by L plus y by square root of the value divided by M plus z by square root value divided by N is equal to 1. This is the intercept form. Agreed? All of you, please tell. The intercept form I have written. So x-intercept, if we have considered, is nothing but square root of L square by A plus M square by B plus N square by C whole by L comma 0 comma 0. This is x-intercept. Agreed. Similarly, you will have y-intercept and z-intercept. Same number will come. So y-intercept is nothing but 0 square root of L square by A plus M square by B plus N square by C whole by M comma 0. This is y-intercept. Similarly, you will get z-intercept. Are you getting the idea? Please tell all of you. Right. So, since we are calculating the centroid of the triangle, so let us take that x1, y1, z1 is the centroid. Of triangle PQR. You have got all the three vertices, first vertex, second vertex and third vertex you got. So applying the centroid formula, you have x1, y1, z1 is equal to 1 by 3L into square root of This is the centroid. Clear to all? After applying centroid to the vertices, I got it. Now, I have to eliminate the values of LMN. Why? Because my question part is nothing but I need to find the locus of the centroid. As I have considered that x1, y1, z1 is the centroid, I have to obtain an equation involving only x, y, z. LMN should not be there. So for this, comparing the coordinates on both sides, I have to modify it by doing some arrangement on it, so that I will get an equation in terms of x, y, z only. LMN will get eliminated, right? That is the actual thing I have to do. So for this, I am doing like the part as so. If you take the first coordinate, 3L comes this side, I can take squaring on both sides. That's true. So I will do that. 3L x1 whole square is equal to L square by A plus M square by B plus N square by C. Again, 3M y1 whole square is equal to then you have this is the thing you got. So I want to do the modification as I will write it as the part is taken as, so I will divide both sides with 1 by ax1 square. So what happens? Nine L square by A is equal to if you add that, you will have the part as these two things gets cancelled. So the required locus is nothing but this is the locus we have. Please check on that. So in order to cancel element, so I want to cancel L square by A plus M square by B plus N square by C. So for that, I have considered 1 by ax1 square for the first, 1 by b y1 square for the second, 1 by c z1 square for the third. So I will get this type of notation. Please check on that. This is 9 actually. 9, 9 and 9 here. Right? Now I will give some problems for you as a practice. You can solve them at your free time. The basic problems based on the previous class session. just take a note of them. Show that x plus 2y plus 3z equal to 2 touches the conicoid If you have done, you neglect that, otherwise you practice this. Second, find the equations to the tangent planes to the surfaces Second problem is so these two things you take it as a practice, because that will refresh your knowledge based on the formulas what we have done so far. So with your permission, I want to conclude our today's session here. So tomorrow we are going to do, the next class on Saturday, we are going to do more problems on conicoid chapter. So earlier, majority of the questions are framed on ellipsoid. Later, some parts will be discussed on hyperboloid of one sheet or paraboloid. Not that much. Majority of the problems are concentrated on ellipsoid only. Right? So once you get the context in a clear manner, then it is very easy to solve them. So if you have noted, then let us wind up our discussion here. Thanks for all of you for your good listening. If you want add something, you can add upon. Thanks.